All right, guys. Good evening to everyone. If you are online, do well to signify so we can start this section. In this section, I'll be doing an introduction to a very key aspect in chemistry called organic chemistry. So, irrespective of the class you are, this particular aspect in chemistry is very vital for your exam. So you must listen carefully. So let's start. So if you are online, do well to signify so we can start right away. I'll be walking through a very key aspect in chemistry called organic chemistry. All right. So I'll be walking through a very key area in chemistry called organics. So if you are online, do what to signify and ensure you share this live. Ensure you share this live videos. Ensure you share this live video. All right. Ensure you share this live video. All right, everybody. Good evening to you all. Ensure you share this live video with your friends. So let's see how it goes now. I'll be walking through organics this evening. So let's start. Make sure you share this live video with your friends. So, organic chemistry. Now, first of all, whenever you hear organic chemistry, there is a very, very key element that should come to your mind, and that element is carbon. Carbon is one very vital element studied in organic chemistry. And I believe everybody knows that carbon is symbolized as C. Now, another key thing you should know about carbon is that carbon is tetravalent. What do I mean by this? It's very simple. Carbon is a tetravalent element. What do I mean by this? I mean that carbon being tetravalent, it means that the maximum number of bonds that should surround carbon as an element is 4. Tetra simply means 4. I believe you are following me. So carbon is what? A tetravalent element. Now, moving further, you must also understand here that carbon as an element exhibits some unique properties. What did I say? Carbon as an element, it exhibits somewhat unique properties. It exhibits somewhat unique properties. So it's very vital. Guys, ensure you like this video and share with your friends. It's very vital you know the unique properties of carbon. So what are the unique properties of carbon? What are the unique properties of carbon? What are these unique properties of carbon? Number one of the unique properties that carbon undergoes what we call catenation. In chemistry, carbon is the most extensive catenator meaning that carbon is the only, like, is one of the elements, or is the most element that can undergo catenation the more. Now, we already established that carbon is tetravalent. What did I say about catenation? Catenation is the ability of carbon to form multiple. All right, catenation is the ability of carbon to form long chains. Very simple. Now, this is what I mean. This is carbon forming long chain. This is carbon forming long chain. So what will I say? This is catenation. You can see that this chain carbon is forming, they are all chains that are made up of one stroke. This one stroke, they call it single bonds. Relax, we are just starting. So basically, also carbon can also form long chains with itself, but this time around, carbon can be formed by two bonds or double bond. It's called double bond. And you get my point. So if you observe now, this chain is formed by a double bond and as well as single bonds as well. So you should understand here that the ability of carbon to form long chain with itself, either it is single bonds or double bonds or triple bond, we simply say that is regarded to be called what? Catenation. You can see now, it's forming long chain with itself with single bond, long chain with itself with double bond, long chain with itself with what? Triple bond. So what are we going to call that? We simply call that what? Catenation. I believe you guys are following me. So that's one of the unique properties of carbon. Carbon undergoes what? Catenation. What's another unique property of carbon? That is called hybridization. That is called what? Hybridization. Now, on hybridization, I won't really stress on that aspect. There are other things I have to tell you guys here. So just know that carbon also undergoes what we call what? Hybridization. That is another unique property of carbon. So, now, I'm about wiping the board. I believe I can wipe. Ensure you share these live videos with your friends. So let's progress. Alright, so let us move over to other things you should take note of whenever we study organic chemistry. Now, I've said that carbon undergoes has some unique properties which we've talked about, alright? But there are other things you have to note on this aspect of chemistry. Alright, so moving further, guys, listen. In organic chemistry, we study a very special group of compounds called hydrocarbons. What did I say? In organic chemistry, we study a very, very vital group of compounds called hydrocarbons. Called what? Hydrocarbons. What are hydrocarbons? These are compounds. Hydrocarbons, what are they? They are compounds that contain carbon and hydrogen only. Are you there? So this is what we call hydrocarbon. Hydro and carbon, but we'll not write C before H. Do you understand? I can say write H before C, anyone. But you should know here that hydrocarbon, they contain carbon and hydrogen only. So now we now have to talk about how they are being classified. This is a very key aspect you should take note of. Hydrocarbons are classified into two major groups. What did I say? Hydrocarbons are classified into two major groups. What are these groups? We have the aliphatic hydrocarbons, and as well as the aromatic hydrocarbons. What did I say? We have the aliphatic hydrocarbons and as well as what? The aromatic hydrocarbons. The aliphatic hydrocarbons and as well as what? The aromatic hydrocarbons. And I'll be explaining what I mean by something, an hydrocarbon being aliphatic and also another hydrocarbon being what? Aromatic. So you just listen carefully. So where's these guys coming from? Aliphatic and aromatic hydrocarbons. They are coming from what now? Where's aliphatic and aromatic coming from? They are coming from hydrocarbons. Are you following me? Now from the word aromatic hydrocarbons, You have to just quickly note this. Any compound that is under the aromatic hydrocarbon has a good aroma. Are you not seeing it? Aromatic aroma. So you should note that any compound that is in this group, they smell nice. They have a pleasant smell, which we are going to talk about. So for aliphatic, I will talk about them. Just relax. For the aliphatic hydrocarbons, there are two groups. For the aliphatic, what did I say? The aliphatic hydrocarbons are of two groups. What are they? We have the cyclic. We have the cyclic aliphatic hydrocarbons, and as well as the acyclic aliphatic hydrocarbons. Are you following me? So aliphatic hydrocarbons are of two groups. We have the cyclic aliphatic hydrocarbons and the acyclic aliphatic hydrocarbons, whereby when we just talk about aromatic hydrocarbons, they are literally benzene and its derivatives. Benzene and its derivatives. So this must be noted. So now, this guy I want to stress on for the sake of your exam. For the acyclic hydrocarbons, they are majorly divided into three groups, which are the alkanes, which are the alkenes, and lastly, which are the alkynes. Are you there? So for the acyclic hydrocarbons, ensure you like this video and share with your friends. All right, so we have the alkanes, alkenes, and alkynes. Are you there? So these are the acyclic hydrocarbons. These are what? The acyclic hydrocarbons. All right. So basically, what are the now? Let me now explain what aliphatic hydrocarbon mean, and as well as aromatic hydrocarbon. Now, this is the difference. Aliphatic hydrocarbons are hydrocarbons with straight chains. Listen, aliphatic hydrocarbons are hydrocarbons with straight chains. Are you not seeing this thing being straight? Now, another thing you should know about aliphatic hydrocarbon, they have straight chains. They don't have branch chains. They have straight chains, and as well, a very key thing about them is that aliphatic hydrocarbons don't have the benzene structure or don't have the benzene rings in them. This is what I mean. Because when we talk about aromatic hydrocarbons, they are literally the benzene and its family, and this is how benzene is drawn. Are you guys following me? This is how benzene is drawn. Or put another line inside here, put another line here, and put another line here. Me doing this, there's a reason I will explain very soon. But you should just understand here that the aliphatic hydrocarbons are hydrocarbons that have straight chains, and they don't have the benzene ring in them, which is this. So this thing I just drew is benzene. Benzene can also be drawn like this. If I don't draw it like this, I can draw same shape like this and then put a ring inside. Are you following me? So if I don't draw this, I draw this. Both of them are literally benzene. But we'll come to this. So you should understand here that aliphatic, they have straight chains and they don't have the benzene ring in them or the benzene structure. Whereby aromatic hydrocarbons, they have the benzene structure in them. So that's the difference. But the other things you should note, which I'm going to tell us in the course of this lesson. And guys, ensure you like this video and share with your friends. So that is for that. Now, we've talked about alkanes, alkenes, and alkynes, but I have to stress on them because these are the things. This is where we have to start from. So basically, guys, ensure you like this video and share with your friends. All right. So now I want to wipe the board. Then I start with alkanes, alkenes, alkynes, which are under the acyclic. This one I'll talk about it, but just relax. So let me wipe the board. So remember, alkanes, alkenes, alkynes, they are hydrocarbons. They are compounds with carbon and hydrogen only. Put that in your mind. So let me wipe the board. And also ensure you subscribe to my channel if you haven't yet subscribed. And share my lessons with your friends. I have so many video lessons on my channel, both in chemistry and as well as in biology. So guys, ensure you after watching this live, ensure you go there and watch other of my videos. So basically, let's start with talking about the alkanes, alkenes, and alkynes, things you should note for any chemistry related exam you are preparing to write. So then we'll start with alkanes. Alright, we'll start with what? The alkanes. Now if you observe what is happening, alright, I'm coming. Alright, this is alkanes. We also have the alkenes. We have the alkenes. And lastly, we have the what? Alkynes. So if you observe what is happening here, the spelling, the first three letter words are literally the same in all of them. What differentiates them is the three letters that are ends, which here for alkanes is A-N-E that ends it, alkene E-N-E, alkyne Y-N-E. Now all of these set of compounds, what are they called? They are hydrocarbons. What did I say? They are hydrocarbons. Now you listen very well. So we already know that these compounds should contain what? Hydrogen and carbon only, because from this thing alone they can ask a question, and it's very simple. I will ask us question very soon. So everybody notes this. All these guys have another name. If you have to call them alkanes, you simply call them paraffins. So alkanes are also called paraffins. Alkenes, what are the other names? Alkenes are also called what? Olefins. And lastly, alkynes are also called acetylene. Now, note this also about them. Alkanes, they are all single bonded. Alkenes, they are all double bonded. Alkynes, they are all triple bonded. Are you there? So this is something we should take note of these guys first of all. These things are very vital. These things are very, very vital. Guys, ensure you like this video. Don't just watch without liking. Ensure you like and share with your friends. Pick the link and share to your various WhatsApp group. Alright. So now, moving further, what do we do next? We've established that alkanes are also called paraffins, alkenes, olefins, alkynes, acetylene. Now, I want to draw a structure on the board. Though on my video lesson here on YouTube, I have a full video lesson on how to name organic compounds from the scratch. So it's essential you go watch that video so as to learn how to name organic compounds. Any type of organic compound, I've explained it on my channel. So all those ones are very easy. You just relax. Then I want to draw a structure on the board. Let us identify the structure together. They are all easy. Just watch, listen very well. This is a structure. You don't have to be scared about the structure. Alright. You don't have to be scared about it. This is a structure. This is an organic compound. So let's say here is H and here is H. And why am I actually writing H around the carbons? What did I tell you? We are talking about hydrocarbons. And I believe you know that hydrocarbons are compounds with carbon and hydrogen only. Do you understand? So no other elements should be here. So that's my point. No other element can be here. So you're looking at this structure, even if you don't know much about organic chemistry, but you can identify what type of compound this is. It's very simple. This is an hydrocarbon. We have agreed. This compound, is it an hydrocarbon? First of all, look at it very well. Is this compound an hydrocarbon? Yes, it is, because it contains carbon and hydrogen only. What's another? So we have many types of hydrocarbons. So then, what do we now do next to identify it? We have to look at the bonds around this compound. I not see that single bonds around. Then this tells you that, oh, this compound is actually what? Is it an alkane, or an alkyne? This compound, there is single bond everywhere. So then this compound is an alkane. Are you there? This compound is what? An alkane. But alkanes have different members. Alkane, let's call alkane a family. Do you understand? We know we have different families in Nigeria and in the world. So then alkane is one family. So inside this family of alkanes, there are various members. Are you there? So that's what I mean. So this compound is an alkane. But what type of alkane is this? That will be the question you asked me. What type of alkane is this? It's very simple. You just follow me. Listen, I'm about doing something here. Follow me. Now, in organic chemistry, when we have a compound, this applies to all type of compounds in organic chemistry. So it's not just alkane I want to talk about now. I want to talk about all families in organic chemistry. Any compound in organic chemistry that just have one carbon in it, then I call that the name of the compound should start with met. That's my point. The name of the compound should start with what? Met. If that compound in organic chemistry has two carbon, what should the name start with? I'm telling you now, if you don't know, it should start with X. Are you there? So if we have another compound in organic chemistry that has 3 carbons in it, what should the name start with? Prop. Do you understand? If that's 4 carbons, what should the name start with? Bute. If that's 5 carbons, what should the name start with? Pent. Alright, it's very essential you know from number 1 to number 10, so it will help you a lot. So moving further, let me take it up here. Let's say an organic compound has 6 carbons. What should the name start with? Hex. If it has 7 carbons, what should the name start with? Hept. If a compound has 8 carbons, what should the name start with? Oct. If a particular compound has 9 carbons, what should the name start with? Non. And if it has 10 carbons, what should the name start with? Dec. So I believe you've seen all of these things written. So then we can now put it over to the name of this compound. We can now simply name this compound. These are some basic rudiments about naming organic compounds. So moving further, what do we do next? Looking at this compound, even if you are not too strong in naming organic compound, which I've created a video on how to do that. So go watch that lesson. You can name this compound very easily. So then, how many carbons does this compound have? This compound has 2 carbons, so then the name should start with 8. Do you understand? So then, now looking at the bonds around the carbons, the bonds around the carbon majorly. We are looking at the bond that holds the carbons majorly. That's what we're looking at. So the bond holding these 2 carbons together. Is it not single bond? Then he said that, oh, this compound is actually an alkane. Then I take the last 3 names, add it to this. So what have we formed? Ethane. What have we formed? Ethane. So this is the name of this compound. I believe it's clear. So I want to give you guys your own now. Let me see how far you can solve the question. So I want to wipe those board and put something else. They are all simple. They are not difficult at all. So let's wipe. I want to wipe this now. So now these are another structure entirely. You don't have to be scared about how I am forming the structures or something. First of all, know how to name the structure. This is another one entirely. This carbon bonding to a single bond, another carbon, and then, alright, and here is H, and here is H, here is H, here is H. First of all, I know you are surprised, why did I not put another bond here? Why did I not put another bond here to put H? I know that's your mind. So I told you already that carbon is tetravalent. The maximum number of bonds that should surround carbon is 4. So it's not 4 bonds that surround this carbon. Yes, looking at this carbon, it's 4 bonds that surrounding it. So look at it. 1, 2, 3, and 4. This carbon is 4 bonds that surrounding it. So if I put another extra bond here, this carbon has disobeyed the rule of carbon. Do you understand? The rule of carbon says that it should be how many bonds? It should be how many bonds? 4 bonds, not 5 bonds. So if I find out here I've disobeyed, so that's why it's like this. Same applies to this one. How many bonds surrounding is 1, 2, 3, and 4? Do you understand? So that's my point. So now this compound, what should becomes the name? First of all, are you not seeing 2 carbons? Like, are you not seeing this compound has 2 carbons? Then the name should start with X. So moving further, what do we do next? Now, are you not seeing that? Oh, this compound. Now, whenever you just see another type of bond apart from this single bond, so that bond you are seeing takes the name. So then this guy has a single bond. That's why I said look at the bond holding the 2 carbons first, or the 3 carbons, as the case may be. We should talk more. You understand? So it's 2 bonds that's holding. Then this guy is an alkene. So then I keep just come here and take the last name. So this guy is called ethene. Do you understand? So that's how it works. They are all very, very easy. Can you guys hear me? Hope you guys are following. So that is for that. So let's take another example. All right. Alright, now looking at this structure, let me put my H around H, H, and H. Are you following me? What should I do next? Am I to put any bond up, down? No, because this carbon is already 4 bonds. Look at it now. 1, 2, 3, 4. 4 bonds correct. Look at this one. 1, 2, 3, 4 correct, and this one is correct too. So then, How many carbons does this guy have? It has 3 carbons. Then the name should start with prop. Do you understand? Prop. So then, since it has 3 bonds, wow, it has 3 bonds. Because when you just say another type of bond, it takes the name. It takes the name. Wow, this guy's name should be something like propane. Propine, alright? Yeah, propine. Alkyne, propine. Do you understand? But then we have to be very careful. We have to actually give this propine a number. You understand? We have to give this propine a number. This is rule of naming now. You know, I'm not really dealing with naming, but if you have a number, you have to count. You understand? Where is this propine found? If you count, you can count in both directions. It's simple. It's not hard. Where is this propine found? It's found in carbon 1. Actually, one of the rules in naming organic compounds is that you count forward and backward in the compound. So you can count here 1, 2, 3. This you counting forward. Let's count backward. 1, 2, 3 as well. You count the numbers of carbon. You count the longest continuous carbon chain. This is the longest continuous carbon chain, so you count it both forward and backward. It's one of the rules. I have it on my channel. Go and watch it on how to name organic compounds. So then, looking at this, what do we do next? Looking at it. Now, for you to name organic compounds, then listen. This is the functional group. This is special groups. This is special that gives this compound its identity. That's what we call functional groups. Functional groups they are groups in organic chemistry that give a compound its identity. It determines the chemical property of a compound. That's what functional group does. So then looking at this guy, you have to ensure that this functional group have a low number as possible. Have what? A low number as possible. And this is the functional group. So when you count like this, if you observe, you can see that this functional group is between 2 and 3. It's between what? 2 and 3. And when you count like this, you can see between 1 and 2. Do you understand? So which one should have a low number? This direction. This direction. Do you understand what I'm saying? This direction should have a lower number. But now, you now compare between 1 and 2. Which will you give the functional group to? Is it carbon 1 or carbon 2? That's the point. You ensure that the functional group goes to the carbon with the smallest number, the lower number. So then this compound is actually 1 propine. But between numbers and letters, you use dash to separate it. Class, is it understood? Let me know in the comments. Is it understood? Let me know in the comment section. Is this understood? Let me know in the comments section. So that's for that. You know, here that is empty should contain hydrogen and what? Hydrogen. That's my point. All these stuffs are very easy. They're not difficult at all. So I'll give you your own practice question. Let me see how far you'll be able to solve the question. They're all simple. I want to wipe. I want to wipe. Just try, follow the same rule I've explained and name this one. Though I'm not focused on naming organic compounds right away. I want to teach something else. But let me just give you this one if you can name. You can name it, not if you can. So this one is like, it's still similar. But this time around, it has H, 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 and H. Ensure you name this compound for me. 1, 2, 3, 4. Alright. 1, 2, 3, 4, correct. So guys, name this compound for me. Follow the same rule. You count the number of carbon, give it the name. If it's 3 carbon, you write what it should be there. And then you identify the functional group here. You count forward and backward. The one that have lower number, give it to it. So guys, name it according to how I've explained to us. According to how I've explained. So you guys should name it, name it, name it. Name that compound on the board so we'll progress. For those who are just joining, don't worry, this life will be saved. So after the class, you'll watch it again from the beginning. After the class, you are going to watch everything from the beginning. So nothing to worry about. Alright, prop 2, I know who's saying prop 2. Prop 2, no, give it to the lower number. Don't make that mistake, guys. Tell you guys doing some persons, because some persons not. I said count forward and backward, then it's prop. I know it's prop, but it's propene. Do you understand? Propene. Alright, I have to tell you guys something. Propene. So count forward and backward. 1, 2, 3. 1, 2, 3. The function between 2 and 3. So this one is out already. This direction is out already. So you have to focus on this direction. Sorry, you have to focus on this. This direction is out. 1 to 3 is out. Yes, you can't use this one to come back. Do you understand? So then you have to now give it to the lower number now. When it's between 1 and 2, you give it to 2, to give it to 1. Do you understand? So this 1 propine. Or if you don't know this, please wait for now. If you don't call it 1 propine, you call it prop 1 ine. Just know that between numbers and letter, number later is dash. That's my point. If you don't call it 1 propine, you call it prop 1 ine. Guys, is it understood? Guys, is it understood? I've explained this in the previous example. That's why I just, but let me take it again. First rule, you look at the numbers of carbon the compound has. It has 3 carbons. Oh, then the name shall be prop. Then look at the special group which is found here, which is a double bond. Then is an alkene. Then the name should be propene. So give the propene a number. If you observe, the functional group is between 2 carbons here. When you count, you can't forward and backward. That's the rule. And ensure that you give it to the guy with lower number. Because if you use this direction, it's between 2 and 3. You can't use this now because it's very large. You have to use one that's lower. So you have to come down. And that's the compare between 1 and 2, which you will give to 1. Go to the lower number. Go to what? The lower number. Class, is it understood? Class, is it understood? Let me know in the comment. Let me know in the comment. Is it understood? Let me know in the comment section. So we progress. Is it understood? Let me know in the comment section so we progress to other things to learn. Ensure class, is it understood? So we progress to other things to learn now on this aspect. All right, very good. So now, I'm about wiping the board and I want to tell you guys something very vital. I want to wipe the board. We've not really, these are basic naming of compounds. Go and watch my full video lesson on how I named compounds from beginning till mastery. All types of compounds are there in that video lesson. Explained properly, step by step. So go and watch that video on my channel. So then, now, everybody watch. There's something I have to tell us. There's something very vital I have to tell us now. You can see that, alright, let's take example. Let's use this guy. Alright, this guy has 4 carbons now. This guy has 4 carbons, 4. So then here is H, here is H, here is H, here is H, here is H. So as I'm drawing, just name it for me. This one is simple, very easy. It has 4 carbons, so the name should start with but. Do you understand? But looking at everywhere, it's not single bonds you are looking at. Then you simply say that, oh, this compound is an alkane, so the name should end with ane, so it's called butane. Do you understand? Now, for all of this alkane, just you can't give it any number because there's no like special group, so you just leave it like that. Do you understand what I'm saying? You can't give it any number because there is no what special group. Alkane does not have any special group, which is a functional group. Alkane does not have any functional. That's the point. Because it's your functional group you give number to. There's no functional group here. Everything is just single bonds. Do you understand? Now, there's something better to tell us now. Now, looking at alkane, or looking at any type of organic compound, the bond found in organic compounds majorly is covalent bond. So if you're a student, you're finding it difficult to understand chemical bonding, I've explained that on my channel step by step. All those covalent bond, electrovalent bond, ionic bond, also called electrovalent bond, metallic bond, all those types of bond, coordinate covalent bond, also called dative bond. Go and watch my channel. Just say chemical bonding by Nosbride. Then you will see the video on my channel. Explain step by step. Or you go to my playlist and look for the video. So basically, you should know here that now what are bonds? What are bonds? Bonds are they are like, how am I going to put it now? They are what holds elements together or compounds together, any of them. All these lines you are seeing, these lines, they are the bonds we are talking about. Do you understand? They now have different types. So take note. In organic chemistry, what type of bond is seen majorly in compounds? Covalent bond. Are you not seeing these things? Are you not seeing these lines? And what bond am I telling you that again? Covalent bond. Do you understand? Not just in butane, no, any type of structure, but in alkene family, alkyne, benzene, what type of bond? Covalent bond. Now, this covalent bond I am talking about are of 2 types majorly. They are how many types majorly? 2 types majorly, which include what we call the sigma bond, and the pi bond. What did I say? The sigma bond and what? The pi bond. Take note of what I just said. This covalent bond I'm talking about, there are two majorly. We have the sigma bond and as well as the what pi bond. The sigma bond and as well as what the pi bond. So then we have to now know how to identify the sigma and pi bond. First of all, you should know the symbol of sigma. Sigma is symbolized as this. Pi is symbolized as this, like mathematics 20/7. But that's the symbol. So you have to know how to identify them. Do you understand? You have to know how to identify these bonds. Sigma and pi. Guys, ensure you like this video and share with your friends. Ensure we get to more than 100 likes, which is very possible. So do that now. If you've not liked this video, if you've not shared the video, ensure you share this video with your friends. So I want to wipe this and they get something very, very vital now. Now, how do we identify sigma and pi bond in an organic compound? How do we identify sigma and pi bond in an organic compound? Very easy. Listen. I'm going to use these alkenes, and alkynes. Are you not seeing them? Listen very well because this is a question. This is a question we need to bring all the time in the exams. Chemistry exam, big jam, post-UTME. So listen very well. Now, these are an alkane, these are an alkene, and these are an alkyne. This alkane, we already know that. This is alkenes, and this is alkyne. So then, they can ask you, how many sigma bond is found here, and how many pi bond is found here? Do you understand? That's what I want to calculate for three of them. Listen, how do you determine your numbers of sigma and pi bond? Very easy. Is this not alkane? Is this not alkane? Is this not alkyne? Listen, in any compound at all, you know bonds exist between two elements now. As seen in that carbon bonding to carbon bonding to hydrogen. No, it's not between two elements. So all those straight lines, you should watch out for them. They are the bonds we're talking about. But there are two types. We have sigma and pi. So listen, that first one you see, listen, you know normally now we have something like this. This, you know, normally in a structure we have something like this. This first one you are seeing is a sigma bond. What did I say? This first one you are seeing, listen, oh, this first one you are looking at right now, what's it called? It's always a sigma bond. But any other one that should be added is a pi bond. This is what I mean. The first one you see first is a sigma. Any other one you add is a pi. Any other one you add is a pi. Any other one you add is a pi. So, in terms of what I'm explaining, just listen. For alkanes that are single bonded, listen, in this context, how many sigma bonds can we see here? How many sigma bonds can we see here? 1. Can we see any pi bond attached? No, 0. Do you understand? Let's go back to alkenes. We'll solve questions, standard questions. Alkenes, listen very well. For alkenes, guys, look at it. Listen. I told you the first one is your sigma. Every other one that's added is your pi. So this first one is my sigma. So sigma is 1, pi is what? Because there's 1 added, 1 as well. Do you guys understand? They're all simple. Going over to alkynes, the sigma, the pi. How many sigma? The first one is your sigma. And what is that? 1. Any other one that should be added is your pi. And what's that? 2. Class, is this understood? Let me know in the comment section. Is this understood? Let me know in the comment section so we progress. Is this understood? Let me know in the comment section. If you are just joining, relax. You get access to the video after the class, all right? So that's for that. You have to know these things, so they are very, very vital. Note them. They are very, very vital. So with this information, let's solve some questions. With this information just given, let us solve some question. With this information just given, let us solve some practice question. I just wiped the board. So guys, listen very well. This is a structure. You don't have to be scared. That was simple. This is a structure like this. It has a triple bond. It has a bond. It has this, that's that. Alright, and there are hydrogen around. So your question can come and tell you that how many pi and sigma bonds are here in this structure. They are all simple. I think I'm okay. So how many sigma and how many pi bond? Listen, let's count together. You count. Remember, sigma is the first one you see anywhere at all. Pi is anyone that's added to that first one you see. So now, what's the first one? Even if it's a carbon, hydrogen, carbon, nitrogen, anything at all, but if there is a single bond, it's a sigma bond. So 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma, 7 sigma, 8 sigma, 9 sigma. So the sigma bond here is 9. How many pi? You just go straight to the part with multiple bond. Pi is 2. Do you understand? So we have 2 pi bond. So this is the answer to the question. It's very simple. This is the answer. Are you guys following me? This is the answer to the question. Very easy. Not difficult at all. Count carefully. Don't rush. Count carefully. You don't have to rush. Classes, they understood? Let me know in the comment. So we'll progress. I give you one practice question, then we'll progress. Let me know in the comment. For those who are just joining, you watch the video after the class. So let me know if you understood. Say, yes, I understand. Yes, I understand. That's what you should say. Yes, I understand. Yes, I understand. For those who are following this part now, listen. All right, very good, very good. So that is for this question. It's very easy. So I want to give you guys your own to solve, all right? I want to give you guys your own to solve. Ensure if you haven't yet subscribed to my channel, ensure you do well to subscribe and share with your friends. So let's progress to another question. And this one is for you guys, not me. I won't solve this. You just tell me the answer, then I'll put the answer on the board. So let me give you guys another one entirely. Carbon bonded to, all right, there is a double bond here. There is another one, there is a triple bond here. This compound has multiple bonds. So you should not be scared about how to name it. So name it is simple. I'm not asking you how to name it. I'm asking you to determine the number of pi and sigma. That's my question. So you don't stress yourself with the naming yet. It's not important. So here now it has 4. Here has 4. Correct. And hydrogen everywhere. Hydrogen, and hydrogen. So tell me how many sigma and how many pi bonds are here. Count carefully. Let me count my own first. 3, 4, 5, 6. Alright, let me count again. 1, 2, 3, 4, 5, 6, 7. I'll do my own to your own. 8, 9, 10. Wow, I got 10. Alright, this one will be 1, 3. Alright, let me not say it. Let me count again. 4, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, I'm correct. So let me see yours. You guys should solve that. Guys, ensure you like this video. Don't just watch without liking. Why now? Like this video, share with your friends. All right, Jane got it. Very correct. Jane got it first. Wow. 10 sigma and 3 pi. Very correct. Jane got it correctly. All right, Jane has gotten it. Who else? Nobody else has gotten. Why? Nobody else. You guys should solve. Ensure you get that same answer. So we'll progress to another question, another aspect of chemistry. All right, who else? Osarugwe got it correctly. Very good. Yakubu got it. You guys did well. That's nice. So this, I'm wiping already. So for those who were solving, sorry, I've wiped it, but you have the video again after this section. So you just relax. So I believe we all are clear with this aspect. Now, another thing again, let's progress. We are still on alkenes, and alkyne. Let me why. There's something very vital I have to tell you guys also. We are still on alkenes, and alkynes. Guys, let's get to 72,000 subscribers. Let's get to 72. Ensure you like this video, subscribe to my channel, share my videos with your friends. Let's get to 72,000 subscribers. Currently, we are at 71,000 subscribers. So let's get to 72 right away. It's very possible. So let's do that now. Currently, we are at 71,000 subscribers. So let's get to 7,200. It's very possible. So guys, let's move further. There's something you have to know about these 3 guys also. you should be aware that alkanes, when it comes to hybridization, though there is a reason to why I want to write something on the board, but I will not tell you the reason, just note it. Alkanes generally, any compound that is an alkane, they are all sp3 hybridized. Any compound that is an alkyne, they are all sp2 hybridized. Any compound that is, oh my god, any compound that is an alkene, sp2 hybridized. Any compound that is an alkyne, sp hybridized. Do you understand? Even this guy, which is benzene, the hybridization also is sp3. Are you not seeing that ended here? So take note. Benzene hybridization is what? sp3 hybridized. Benzene hybridization is what? sp3 what? Hybridized. So take note of that. But that's not what I'm going to tell you guys about them. That's not what I'm talking about. Now, there's something else I'm talking about. You should know here that alkanes generally, they are saturated compounds. What did I say? Alkanes generally are what? Saturated compounds. Alkenes, they are unsaturated compounds. Take note of what I just said though. I'm going to tell you why I said they are saturated, unsaturated, and the rest. Alkynes also are unsaturated. They can ask you which of the following hydrocarbons are unsaturated. It's alkenes and alkynes. But the ones that are saturated is alkane. Why? Why? You have a question you ask me. Why have I said all of these things? Guys, like the video, share with your friends. Now, why am I saying all of these things? Let me explain for saturated. What do you understand by the word saturated? Something is saturated. What do you understand by it? Simple. When a compound is saturated, it means that compound is filled. There's no other way you can add something to it. That's what saturated means. But when a compound is unsaturated, it is not filled. There's a way you can add something to it. It's not filled. Saturated, they are filled. This is what I mean. Alkanes, I believe every one of us here, everyone understand what saturated means. When a compound is saturated, like everywhere is filled. There's no way you can add something to it. And I believe everybody seeing me now knows that this compound is called propane. This compound name should have prop because it has 3 carbon and it's an alkane because it has single bonds. And if you observe, carbon rule is tetravalent. It's 4 bonds that should around carbon. 4 bonds. Look at it, 4 bond. So is there any way I can add something again? Is there any way I can do this? No. So this tells us that all alkanes are saturated, not just propane. All of them are saturated. But for the unsaturated guys, for instance, let's take this guy as an example. For instance, let's take this guy as an example. Here is H, 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 here is H. This is also prop because it has what? 3 carbons. But now it has 2 bonds, then it's going to be called propene. But specifically the name should be called 1-propene or prop 1-ene. But that's not what I'm interested in. So what I'm interested in, guys, is this. If you observe, there are other spaces here. And I can literally just break this bond. And I'll cut them into 2. Put one here and put one here. Do you understand? So there is still a way we can feel it. So they are unsaturated. Do you understand? There is still a way we can feel it because they are this is a bond that is straight and I can break into 2. Put one here, put one here. So there's still, it has ways to fill. But for the guys that are saturated, they are all completely filled. There's no way we can add something to it again. Class, is this understood? Class, is this understood about saturated and unsaturated compounds? I understand, so we can progress. Say, I understand, so we can progress. Guys, ensure you like this video and share with your friends. Ensure you like the video and share with your friends. And tell me if you understood what I just explained, so we can go over to something else. Tell me if you understood what I just said, so we can go over to something else. So that is for that. I've explained what saturated compounds are, unsaturated and unsaturated for alkenes and alkynes. So take note of what I just said, so we can progress. Take note of what I just said. I'm about wiping the board now. Alright, so I've said that already, that alkynes, these guys are saturated, unsaturated, and unsaturated. Alright. Now, moving further, there are other things you have to know here. Now, before I talk about that, let me teach you guys something else. Alright? Very good, very good, very good, very good, very good. Now, moving further, the other things you should learn. there is a way, because these are three set of compounds, and sometimes it can be hard to differentiate them in the laboratory. So we perform a test on them where we are going to react them with something called bromine water. So for we to know which one is which one, are you following me? We react them with bromine water. So for instance, I react an alkane with bromine water. Listen, bromine water, when I react, and bromine water has a color itself. So when I react alkane with bromine water, it's usually the bromine water usually always is not decolorized. So meaning that the color of bromine water does not change. That's my point. That's a way to know that, oh, this compound is an alkane. But you should just know here that when bromine water reacts with these guys that are unsaturated, which are, let's say for instance, alkenes, or bromine water reacts with this guy, which is alkynes, then they have the tendency to change the color of bromine water. So bromine water is decolorized. Do you understand? So bromine water plus alkene, bromine water plus alkyne, both of them, they have the tendency to decolorize bromine water. That's my point. So that's a way to actually differentiate between alkenes, and alkyne, reacting them with bromine water. Guys, ensure you like this video. Don't just watch without liking. Share this live with your friends. Share this live with your friends. So that is for that. You can see all what we are doing here. They are all very easy, not difficult at all. Share with your friends. They are very vital. So a way to differentiate between alkenes, and alkyne is basically by reacting, these guys with bromine water. But though, if you observe now, both of them can actually decolorize bromine water. So we can still not know the one exactly that can decolorize. Like both of them can decolorize it. So how can we not differentiate these two guys? There's another test. Do you understand? But I'm not talking about that right now. The other things you should learn. So let's talk about those other things you should learn. So I'm about wiping the board now. There's another terminology you should watch out for, and that terminology is what we call, I'm about writing it on the board now, is what we call something. I want to write it on the board. Guys, ensure you share this live with your friends. Ensure you share this live with your friends. And as well as ensure you subscribe to my channel to help you all improve greatly in chemistry. So then, there's another terminology everybody should watch out for, and it is called homologous series. I don't know if you heard it before, but if you've not, please know it from today. When you see homologous series in chemistry, what does it mean? When you hear the word homologous series in chemistry, what does it mean? That's the question. When you hear homologous series in chemistry, what does it mean? Very easy. Very, very easy. When you hear that, what does it mean? Everybody listen. Homologous series is simply, let me just use layman understanding. Homologous series is like families of compounds. So in real life, I can say your own particular family is an homologous series. So homologous series, like there are families of, families. Do you understand? Different families. But in chemistry, we call them families of compounds. Now, the first family we've been playing with are the alkane family. Do you understand? So you don't have to just think too much. Homologous series is simply families of organic compounds where each member in that family follows a regular structural pattern, and each member differs by a group called methylene group. But those ones are just theory. Just listen. Homologous series are what? Families of organic compounds. The first family we should learn is the alkane family. We have another family you should learn is the alkene family. We have another family you should learn about, which is the alkyne family. We have another family you should know about, which is called the alcohol family. We have another family you should learn about, which is called the alkanal family. We have another family you should learn about, which is called the alkanol family. We have another family you should learn about, which is called the alkanoic acid family. Alright, we have another family you should learn about, which is called the amine family. We have another family you should learn about, which is called the amide family. We have another family you should learn about, which is called the alkyl alkanoate family. Don't worry, all these things are easy. So basically, let's break them one after the other. Though there are several families, but let's break them one after the other. So I've listed so many families of organic compounds, from the alkane family down to alkyl alkanoate family. Some of these families have another name. We've talked about alkane being also called paraffin, alkenes also called olefins, as seen in previous explanation. Alkynes also called acetylene. Now, alcohols can also be regarded to be called alkanols. Alkanols, basic level. Actually, alcohols are of three groups. You have the alkanols, alkenols, and alkynols. Those are basic, and those are advanced. But just notice that alcohols, alkanols, we can call them that they are the same. They are the same thing. Alkanals have another name. If you want to call them the alkanal, you call them the aldehydes. They have the aldehyde family. Alkanones are also called the ketone family. The ketone family, whereby alkanoic acids are also called the carboxylic acid. Also called the carboxylic acid family, whereby the amine family, or does it have another name? For the alkyl alkanoids, they also called the ester family. Do you understand? We have the cyanide family. So that's for that. But basically, let's walk through all of these things. Now, all of these families, which are regarded to be called homologous series, and they have their general formula. They have a very special way we know them. What did I say? They have their general formula. For the general formula for the alkanes is simply arrow bond H. I will explain. Just relax. I'm going to explain. These guys, they don't have like a general formula, so they don't have a general formula. I'll just put slash. I'll just put dash dash. Leave it like that. I know. I'm going to explain. All right. I'm going to explain. They don't have a general formula. All these things I'm talking about now, we call them general formula. General formula. All right. All right. General formula. Well, I'm coming. I'm going to write alkane, alkenes, alkyne up and tell you something about them. Alkanes, alkenes, and alkynes. Now, just note this about them. Alkanes, though they have like a very special formula you should take note of. If they ask what's the formula for alkane, just tell them this. It is CnH2n plus 2. Tell them this. What's the formula for alkanes? To calculate alkanes, tell them CnH2n plus 2. I will explain what that means. Relax. For alkenes, it's just CnH2n. Alkynes is like this, but here is minus CnH2n minus 2. Leave these three things up here, and I will explain properly when we progress. So everybody take note of that. So let's finish the general formula. Alcohols or alkanols, general formula is arrow. I'm going to tell you what arrow means, but first of all, memorize this thing. Arrow bond OH. Just note it. Arrow bond OH. For alkanals or aldehyde, it's still arrow. If your arrow is only starting there, arrow bond CHO. So I will just say arrow bond or CHO. Arrow CHO. For alkanones also called ketone, that is arrow bond CO, another arrow, and they are the same arrow, but because sometimes they are different. To differentiate, I'll put something up, and that thing is pronounced as prime. So let's pronounce it together. Arrow bond CO, arrow prime. So that's carboxylic acid. The other one is arrow bond COOH. Relax. They are all easy. Amine. The other one is arrow NH2. Remember, NH2 is different from NH3. NH3 is called ammonia. Ammonia is a base. Note that. You understand? NH2, NH3, they are different things, so you should note that. Whereby the general formula for the amide, that is ROCONH2, and alkyl alkanoids, also called esters, that is ROCOO, ROCOO prime. That's for esters. ROCOO prime. But relax, all these ones are just story. There's something I have to tell you guys. All these ones are story. There's something I have to tell you guys. Everybody relax, they are all easy. Now, what does this arrow mean? I've been saying arrow. Arrow has a name. Arrow is called the alkyl group. What did I say? Arrow has a name. And what's it called? alkyl group. What is an alkyl group? Very easy. What is an alkyl group? Very easy. An alkyl group is a derivative of alkane. So alkyl is a brother of alkane that loses or that lost one hydrogen atom. Well, let me just say one hydrogen. Let me not use atom and confuse someone. So lost one hydrogen. Now this is what I mean. Let's go back to alkanes. Let's go back to the alkane family. Remember, alkane, what's the general way to get them? It's not their general formula. These are like the formula. Just note this and this one I put that just there's a reason I did it. Just know this thing I just said. This one I put that there's a reason. Leave it alone. Now everybody listen. Let me form something for you. This place will be alkane, whereby this place will be alkyl. Alkane. What's the first member of the alkane family? Something you should know. The first member is methane. Are you there? And I told you how to get it now. And methane, I believe you know that methane has one carbon. Everybody listen. Methane has how many carbon? Methane has how many carbon? One carbon. So then we can use it to calculate the chemical formula for methane. Let's solve it together. Using the general formula, which is CnH2n plus 2. So where that N is the number of carbon the compound has. I'm telling you that methane has one carbon. You should know. Anything that is met has one carbon. So N is 1. So the formula is CnH2n plus 2. So then C1, NYCN upon 1, H2 open bracket 1, I saw N again plus 2. So then C1, H2, because 2 times 1 is 2, plus 2. So you C1H4, which is same as CH4. Do you understand? So this is called methane. Do you understand how I got methane? Chemical formula. Do you understand how I got methane? Chemical formula. Do you understand how I got methane? Chemical formula. Yes, you do. It's very easy. Follow the formula and solve carefully. So how do we form alkyls? How do we form alkyl? Alkyls are formed by removal of one hydrogen from an alkane. This is an alkane. So when we remove one hydrogen, what do we form? CH3. So normally now any compound with one carbon, the name shall be next. But since it's an alkyl, you take the YL methyl. So the alkyl formed from methane is methyl. Do you understand? The alkyl formed from methane is methyl. The alkyl formed from methane is methyl. And what is methyl general formula? What's methyl chemical formula? CH3. There's something I have to tell you guys. You guys have to know something. Alkane, you're looking at how various members. It starts from methane down to infinity. But in chemistry basic level, you have to know the first 10 members of all these families. For methane, now the first member is methane. For alkane, the first member is what? Methane. And let me tell you guys a simple truth. That's why when I was defining something for this, I said something, but maybe you did not take note of it. Every member of this homologous series, they differ by a methylene group, meaning that it's maybe English I'm speaking. Let me take it down. Let me break it down for you guys. I want to wipe. I don't want to wipe this one yet. I want to wipe what I've explained. Listen, everybody. Listen. I want to wipe it. Listen, I've explained what alkyls are, so they are not hard. Because I have to elaborately explain. That's why I'm here, for you guys to understand. Listen, this is CH4. And everybody agreed to me, we made that CH4 is methane. So now, what did I just explain? All members of a particular homologous series differ by a group called the methylene group. Methylene group is CH2 group. So, for we to get the next member of alkane, which is ethane, you should know it now because I've given you guys the first 10 members, like the first X prop like that. So this one is ethane. For we to get the ethane without even going stressing ourselves with the calculations, just add CH2 to the previous member. Adding CH2, which is methylene group, that's the name of CH2. So then you get C2H6, and C2H6 is the ethane. Do you understand? So then, for we to now form the alkyl of ethane, alkyl, they are derivatives of alkanes and lost hydrogen. Remove one hydrogen from here, what will we get? C2H5. So how will you pronounce this? Ethyl. Do you guys understand now? So for me to get the next member is actually propane. because 3 now. So add CH2 as well. So it now be C3 because 2 plus 1 is 3 and H8. Do you understand? Forming the alkyl doing C3H7 and that is propyl. Do you guys understand what is happening? They are all very easy. They are all very easy. They are all very easy. Once it's 6, I'll be ending this live section. Once it's 6, I'll be ending this live section. Once it's 6, I'm going to end the live section. Ensure you watch more videos on my channel to help you improve greatly in chemistry. Ensure you watch so many videos on my channel. I've made so many videos to help you improve. So ensure you watch the video. So that is for that. So that's for that about these alkyl, alkanes, and the rest. And I believe, we can also use a general formula to solve for them. Yeah, don't worry. If I glad they will come and solve questions in organic chemistry. Based on all these things, I will solve questions. So ensure you watch the video from the beginning to the end. So let's progress. I'll be working the road. Now I have to tell you something. Maybe I've not said this. I've said this, but you did not take note of it. Arrow has a name. Arrow, what is it called? Alkyl group. This alkyl group, within alkyl group, has a formula. Alkyl group formula is actually something similar to all these things. It's CnH2n plus 1. They are not the same, but they are similar. Do you understand? They are not the same, but they are what? Similar. So R is what? CnH2n plus 1. So for instance, let me pick alcohol, writing it properly with this, alcohol general formula is arrow bond OH. Do you understand? But writing it properly, removing this arrow and putting the correct stuff, it should be alcohol. Way to write alcohol, general formula should be CnH2n plus 1, that's for the arrow, and then bond OH. So this alcohol properly. Do you understand? This alcohol properly. For the alkanals or aldehydes, it's still the same way. Normally, it's arrow CHO. So then I can just come here and remove the arrow, which is CnH2n plus 1 and CHO. This aldehyde. Same applies. So for this group, they have 2 arrows. Same thing. Let's say alkanones, also which is arrow bond CO arrow prime. So then we're going to be CnH2n plus 1. That's for the first arrow. Bond CO. For the other arrow, still the same thing. CnH2n plus 1. Class, is it understood? Class, is it understood? Let me know. Class, is it understood? Let me know in the comment. Are all these understood? Let me know in the comment. All right. So basically, there's something I have to tell us. So before we end this live, let's just answer some few questions. Though there are other things you'd let know, but let's just answer some few questions. And I believe we've written everything on the board. I believe you've written everything on the board. I want to write the board now. Ensure you like this video and share with your friends. Based on everything I've said, look at this question. Let's solve it together. It's simple. Look at this question. Let's solve together, guys. Which of the following compound? Which of the following compound is not an hydrocarbon? Is not an hydrocarbon. That's the question. Option A, alkane. Option B, alcohol. Option C, alkene. Option D, alkyne. Guys, tell me the answer in the comment section. 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 Tell me the answer. Hillary, very correct. Hillary got it first. Others respond. Hillary got it first. Alcohol. Because hydrocarbon, they contain just carbon and hydrogen. How will alcohol be an hydrocarbon? No. Because I told you already, hydrocarbon is like arrow bond OH. Are you not seeing this guy now? Oxygen, so it has spread everything. So there's oxygen, and I told you carbon, hydrogen. So this is the answer to the question. Do you understand? These guys, they just contain carbon and hydrogen only. Do you understand? So that is for that. that is for that is for that, that is for that, that is for that. So another question. Do there are other things in organic chemistry? There are so many other things. I've said this. If you are still finding it difficult to learn how to name organic compounds, I have it on my channel, so go watch that video. So let's wipe the board and go over to something else. Another possible question you should take note for your exam sake. Now, this another question is very simple and very smart. Very simple or very smart. Very easy, like A, B, C, D. So now, it said the carbon atom in ethane is dash hybridized. So what they are asking us is, what's the hybridized carbons found in ethane? It's simple now. I told you already, I gave you guys 3 things about hybridization just now. Alkanes, alkanes, alkynes. Alkanes, they are sp3 hybridized. Alkenes, they are sp2 hybridized. Alkynes, they are sp. So what's the answer? Tell me. Remember, you should know where alkane belong to. You should know where alkane belong. Sorry, you should know where ethane belong to. Is ethane an alkene? No, the answer is sp3 now, because sp3 is the abbreviation for what? Alkane. And then ethane is an alkane. That's why the answer is sp3 hybridized. Though there is a reason, but just take note of it. All right, there is a reason, but just take note of it. That's for this question. That's for this question. That's for this question. So let's progress to another question if time permits. All right, I think it's almost time. So guys, I see you guys when I see you guys, by God's grace, in my next section. We are done for this section. If you haven't yet subscribed to my channel, ensure you subscribe and share the videos with your friends, and share this lesson. Even if the video will be saved, so you can share it to your friends, and so that they can learn things about organic chemistry. So we are done for now. I see you guys and see you guys. God bless you all, and I wish you success in your forthcoming exams. All right, so we are done for now, guys. Bye, guys.